Imagine a car's tailpipe, and instead of, thick black smoke, out comes just water vapor. Seriously, sounds like pure science fiction almost. But for Toyota, that's a future they are actively building. Pretty amazing stuff.
Welcome to IT Playground Podcast, where technology meets innovation. Join us as we explore the latest trends, insights, and expert opinions on all things IT. And today, we're diving deep into Toyota's hydrogen journey. It's surprisingly diverse, actually, and often kind of misunderstood. Our mission, let's call it that, is to unpack why Toyota isn't just betting everything on battery electric vehicles, and how hydrogen fits into their bigger picture for, well, a cleaner future.
Yeah.
We'll try to make the complex tech stuff understandable, maybe even a bit fun.
Yeah, absolutely. We're looking at some pretty detailed reports on their progress, and it covers both fuel cell electric vehicles, FCEVs, and these hydrogen internal combustion engines, or HICEVs. And the core idea, the really cool part, is that both mainly just produce water vapor, clean at the tailpipe, whichever tick you're talking about. Okay, so let's get into this multi-pathway idea Toyota has for decarbonization. It sounds like they're deliberately not putting all their eggs in one basket. So hybrids, plug-in hybrids, battery electric, and hydrogen, a whole portfolio.
Exactly. It's a really pragmatic strategy when you think about it. There's so much uncertainty globally, right? Building out charging infrastructure everywhere, getting enough raw materials for batteries. Plus, different customers have different needs, different regions have different energy sources. Toyota's leadership has been pretty blunt about it. BEVs aren't the only way, and having many options is crucial. It's about flexibility, really.
It makes sense, like a balanced investment strategy, right? Don't bet the farm on one stock. And wow, they've been into hydrogen for a long time.
Oh yeah, a very long time, over 3 decades now. It actually kicked off way back in 1992 with their first fuel cell vehicle concept. Then by 2005, they had a fuel cell hybrid vehicle, the FCHV. And get this, by 2008, it had already clocked over 1 million testing miles. So, launching the Mirai in 2014, the first mass-produced FCEV, wasn't some sudden thing. It was, well, the result of a marathon.
A marathon that seems to be picking up pace now, though. July 2023, they set up this hydrogen factory. Sounds like a big step. What's the goal there? Centralizing everything.
It's a huge deal. The idea is to really accelerate commercialization. They're targeting a 37% cost reduction through better tech, economies of scale, building things locally, and that could even hit 50% if they manage to secure orders for 200,000 units by 2030. That's ambitious. And it's about localizing R&D and production in Europe, China, North America, and boosting partnerships like with BMW, Air Liquide, VDL Group, building the whole ecosystem.
Right, the ecosystem. Okay, let's look at the two main paths for the vehicles themselves. First up, FCEVs, fuel cell electric vehicles. The quiet revolution, some call them. How do they actually work?
So think of an FCEV as basically an electric car that makes its own electricity on board. You have hydrogen stored in tanks. That hydrogen combines with oxygen from the air across a special membrane, the fuel cell stack, and generates electricity. That electricity powers the motor. And the only thing coming out the tailpipe, pure water vapor, H2O. So it's zero emission, right where the car's driving. That's great for local air quality. Of course, how the hydrogen itself is made matters for the overall footprint, if it's gray hydrogen from fossil fuels, but the car itself runs clean.
Clean enough to water your plants with the exhaust. Maybe don't try that. And the flagship for this is the Toyota Mirai. Mirai means future in Japanese, right? World's first mass-produced one back in 2014, now in its second generation. What's the performance like?
Pretty impressive, actually. The 2025 model gets an EPA estimated range of 402 miles. And the real kicker, like you said, is refueling. Just 3 to 5 minutes at a hydrogen pump. That's way faster than charging most BEVs.
That's a big advantage. And Toyota offers incentives, too, like free fuel.
Yeah, they've offered things like up to $15,000 worth of complimentary hydrogen, plus extended warranties on the key fuel cell parts. They're trying to ease people in.
So with all that, why aren't they everywhere? What's the catch?
The catch. It's that classic chicken and egg problem. As of late 2022, global Mirai sales were around, 21,500 units total. And more recently, sales have really dropped sharply in key markets, like 91% down in Europe, 86% in the US in one recent quarter.
Ouch.
Yeah. People won't buy the cars if there aren't enough places to refuel them conveniently. And companies are slow to build stations if there aren't enough cars on the road demanding hydrogen. It's like having this amazing new phone, but there are hardly any cell towers. Kind of limits the appeal, doesn't it?
Definitely limits it. Okay, let's switch gears to the other path. HICEVs. Hydrogen Internal Combustion Engines. It sounds like Blending old tech with new fuel.
It's a good way to put it. They basically take a conventional gasoline engine's architecture, pistons, cylinders, the whole setup, but redesign it to burn high-pressure hydrogen directly. So instead of a chemical reaction making electricity like in an FCEV, here you're actually burning the hydrogen to drive the pistons.
Huh.
The main emission is still water vapor, so it's virtually CO2 free at the tailpipe. You get the sound, the feel of a regular engine, but running on clean hydrogen.
Okay, so familiar feel, clean fuel.
Mm.
But burning hydrogen, isn't that really hot? Does it create other problematic emissions like Nauticanax nitrogen oxide?
That's a sharp point. Yes, the high combustion temperatures can produce nanocounts, but Toyota's anticipated this. They use advanced exhaust after-treatment systems, specifically selective catalytic reduction, or SCR, same kind of tech used in modern clean diesel engines. It converts the NOx into harmless nitrogen and water, so they can meet really strict emissions rules, like Euro's 6.
And they're really pushing this tech, even racing it. I heard about a hydrogen-powered Corolla in an endurance race with Toyota's own president driving.
That's right. Akio Toyoda himself has been behind the wheel of the rookie racing Corolla Sport H2 concept in the Super Taikyu series. Talk about commitment. And racing is the ultimate test bed, isn't it? It's forced them to rapidly improve things. They've boosted power to be on par with gasoline engines, slashed refueling times from 5 minutes down to about 2, and even trimmed weight like 88 pounds off.
Wow, that's fast progress. Are they testing these outside of racing too?
Oh, yeah. They've run a Corolla Cross hydrogen concept through winter tests in Japan and summer tests in Australia, and they've even put a hydrogen V6 turbo into a HICE van for trials down under. Plus, there's development with Yamaha on a bigger V8 hydrogen engine, aiming for something like 444 horsepower. So they're serious about HICEVs too.
But I imagine there are some unique engineering hurdles with burning hydrogen directly compared to gasoline.
Definitely. Hydrogen ignites differently, burns much faster, like 8 times faster than gasoline. That requires totally redesigned fuel injectors, which they developed with Denso. And managing the intense heat is critical. They've developed special high-heat parts. And even patented a really interesting water-cooled design where they inject water into the combustion chamber to help manage temperature through evaporation.
Injecting water.
Yeah.
That's clever. What about storing the hydrogen itself? That seems like a challenge for both types of vehicles.
It is. Hydrogen has low energy density by volume. So for gaseous hydrogen, you need super high pressure tanks. We're talking 10,000 psi, maybe even higher. The alternative is liquid hydrogen, but that has to be kept incredibly cold, like minus 253 degrees Celsius.
Minus 253. Wow.
Yeah, cryogenic temperatures. That brings its own issues, like keeping pumps durable at those temps and dealing with fuel boil-off. It's complex stuff. Way harder than parallel parking, let's put it that way.
Huh. Okay, so we've got these advanced vehicles, FCEVs and HICVs, but you mentioned the ecosystem earlier. The tech alone isn't enough, right? You need the fueling stations, the hydrogen production.
Absolutely critical. And Toyota's not just waiting for others to build it, they're investing strategically. Collaborations with companies like Air Liquide and Iwatani are key, especially focusing on commercial vehicles which need high-flow, fast refueling, similar to diesel pumps. And a really impressive example is their Trigen system down at the Port of Long Beach in California.
Trigen, what does that do?
It's amazing. It takes renewable biogas, like from waste, and uses it to produce 3 things: hydrogen, electricity, and water, all very efficiently. We're talking about 1,200 kilograms of hydrogen a day, 2.3 megawatts of electricity, 1,400 gallons of water. And it's not just a demo project. It's powering about 30 of Toyota's own fuel cell trucks operating at the port right now. Real-world logistics.
Wow, like a mini clean energy plant.
Exactly. And they're working on other innovations too, like with HRS and NG on tech that cuts refueling time for long-haul trucks down to maybe 12 minutes for a 900-kilometer range.
So they're even getting involved in making the hydrogen, not just using it.
That's right, vertical integration, as you said. They're working with Toyota in Japan on electrolysis, splitting water into hydrogen and oxygen, ideally using renewable power to make green hydrogen. And they're exploring other routes too, like getting hydrogen from methane captured from animal waste or landfills, diversifying the hydrogen sources as well.
Okay, bringing it all together then, we see this multi-pathway strategy. Where does hydrogen really fit best? Where does it have a clear edge over batteries?
The clearest advantage right now seems to be in heavy-duty transport. Think big trucks, long haul. Toyota's putting its own production-level FCEV Class 8 trucks, the big rigs, into service, running routes from the Port of Long Beach. These trucks can perform like diesel trucks, haul heavy loads, go maybe 400 kilometers between refueling, but with 0 tailpipe emissions. Battery electric trucks struggle with the weight and charging time needed for that kind of work. So hydrogen is a really strong contender there.
And it's not just trucks. Toyota's fuel cell modules are going into stationary power generation too, like a 1 megawatt system providing backup power at the National Renewable Energy Lab, replacing diesel generators.
And other companies are clearly seeing Toyota's leadership here. You mentioned BMW. They released patents too. Yeah, they made over 5,000 hydrogen-related patents available royalty-free years ago, which was a big move to try and kickstart the whole industry. It shows they see themselves as enabling the broader hydrogen economy, not just selling their own cars. And yes, the partnerships are key. BMW is using Toyota's next-gen fuel cell stack for a vehicle planned by 2028. Daimler Truck, Volvo, Mercedes-Benz, they're all working on fuel cell trucks. And some are already using Toyota's fuel cell technology in things like Brightus. It's becoming a platform.
So it feels like momentum is building, but there are still big challenges. Infrastructure seems to be the main one.
Absolutely. The lack of widespread, convenient hydrogen refueling stations is the biggest bottleneck. Most stations are clustered in just a few areas like California. And then there's the cost and scale of producing truly green hydrogen using renewable electricity for electrolysis. That needs to come down significantly.
So it's not a perfectly smooth road ahead, but they're definitely building the bridges as they go.
That's a good way to put it. So the key takeaway for you listening is really understanding this multi-pathway approach. Toyota's playing a long game. Hydrogen is a critical piece, especially for those heavy-duty uses where batteries face limitations. It's not about hydrogen versus electric. It's about having the right tool for the right job, region by region. This diversified strategy helps you see beyond just the EV hype and appreciate the sheer amount of innovation happening across the board to get us to a carbon-neutral future. It's complex, but also quite adaptable.
So maybe a final thought to leave you with. As you think about the future of how we move around, how we power things, where could hydrogen fit in? Maybe not just for cars, but for those big industries that keep everything running. Are we sometimes maybe a bit too quick to write off technologies that just aren't mainstream yet? We genuinely love to hear what you think. What part of Toyota's hydrogen story surprised you the most? Biggest challenge, biggest opportunity? Let us know. Thanks for tuning in to IT Playground Podcast. Join us next time for more tech talk, insights, and innovation. Don't forget to subscribe and follow us for more.